Okay, good afternoon everyone. Last meeting ang diniscuss natin ay motion, okay, in one dimension. Okay, motion along a straight line. Ngayon, ang i-discuss natin or extend natin yung discussion into 2 or 3 dimensions. Makikita natin na sa consequence, we'll also tackle yung idea ng curved motion, okay, specifically yung projectile motion. Okay, and as another application of motion in 2 dimensions or 3 dimensions ay yung motion in a circle, okay, or motion along a curve. Okay, so yun yung gagawin natin ngayong araw. Okay, to discuss motion in 2 or 3 dimensions, syempre, i-revisit natin yung definition natin ng position. Okay, so we define the position vectors before as x. So that's the position along x, and then y, position along the y-axis, and then z, position along the z-axis. We can now define a general vector that includes all of this, okay, in terms of the unit vector. Okay. So we define a position vector R. Okay. So R, okay, which includes as components yung position vector X pointing along the x-axis, and then yung position vector Y, which is moving along the y-axis, and then kung 3 dimensions, yung position vector, yung position Z multiplied by yung unit vector k hat. Okay, so we call yung x, y, and z as the coordinates of the particle's position. Okay, so yung x, y, and z, so yan yung coordinates of the particle's position. Okay, and this we refer to as the position vector. And then of course yung I hat, j hat, at saka k hat ay yung unit vectors natin. So we can see yung unit vectors na yun we can see yung position vector na yun dito sa graph na ito. Yung position vector is this blue line, okay? And it has coordinates x, y, at saka z. Okay? So yun yung nakikita natin na x, y, at saka z dito sa equation na ito, sa equation for the position vector. And that's, yeah, so ganyan natin siya i-define ngayon. Okay? Okay, so now that we know that, we can proceed to define yung average velocity and then yung instantaneous velocity. So if you recall, okay, so recall na yung average velocity in one dimension is just delta x over delta t. So yan yung para sa x-axis. Pero ngayon ang tinitignan natin na yung vector na. So position vector na. So in this case, we have for the position vector, okay, this expression. Okay, sorry. Hindi position vector, but the average velocity vector. Okay, to be delta r over delta t. Na kung saan yung delta r is the final position minus the initial position. Okay, and if we divide that by delta t, then we have the vector ng average velocity. And both R2 and R1 are vectors, so we can subtract R1 from R2, and that's what we see here in the figure. So that's graphical subtraction ng vectors. If you recall, to subtract vectors graphically, all we need to do is to connect yung buntot ng R1 at saka ng R2 sa isa't isa. And then we draw a line from the subtrahend to the, from R1, okay, kasi yun yung isi-subtract nyo from R2. So from R1 to R2. Okay, so yun yung delta R natin yan. Okay, so yung direction ng delta R will be the same direction as the average velocity. Okay, and then if you divide delta R by delta T, you get the magnitude of delta T. Okay, now to define yung instantaneous velocity, okay, if you recall, the instantaneous velocity is equal to the limit as delta T approaches 0 of the average velocity, okay, along one dimension, or the limit as delta T approaches 0 ng delta X delta T. So this becomes dx dt. Okay. Now, ganun din yung mangyayari sa instantaneous velocity vector. You simply take the limit of the average velocity vector as delta T approaches 0. So we're essentially taking the limit of delta R over delta T as delta T approaches 0, or this is the time rate of change, of the position vector. Ganun din yung interpretation. So this essentially is the tangent line at a particular point on the particle's path. So dito sa figure 3.3, yung particle path is defined here. Okay, and if we select a position P1, okay, na makikita nyo rito, then at position P1, you draw a tangent line. So yung tangent line at P1 has this shape, okay, and yung tangent line na yan, okay, will have the direction of the instantaneous velocity at P1. Okay, then kung titignan naman natin yung P2, if you draw a tangent line at P2, ganyan yung mag-iitsura ng tangent line, at yung tangent line at P2 will be the velocity, okay, of the particle at P2. Okay, so that's quite straightforward naman. Now, ano yung tawag dito? Ano yung nadagdag na information dito? Since this is a velocity vector, then that means that it also has components tulad dun sa position vector. Yung velocity vector ngayon, we can write as velocity vector, we can write as diba, dr dt, okay, instantaneous velocity ito. So this means na d dt, and then yung position vector na x I hat plus y j hat plus k, plus z k hat okay, and if we tawag dito, take the derivative term by term, then we end up with dx dt I hat. Okay, walang derivative yung unit vector, di ba? Kasi it's just a unit vector, so it's constant. Plus dy dt j hat plus dz dt k hat. Now, itong dx dt ngayon is nothing but yung velocity, instantaneous velocity along the x direction. And then yung dy dt is the instantaneous velocity along the y direction. And yung dz dt is the instantaneous velocity along the z direction. So v sub z k hat. Okay, to get the magnitude of the velocities, we simply use this equation. Okay. Now, it's not straightforward, okay, to get yung tawag dito, yung angle or yung direction, kasi 3 dimensions itong pinag-uusapan, pero in 2 dimensions, okay, then yung expression for the magnitude of the velocity, so magnitude to, no? So expression for the magnitude of the velocity in 2D ay vx squared plus by squared square root, and this is nothing but tangent inverse of vy over px. Okay. Now, dun sa figure, ang ginamit na expression, ang ginamit na direction is yung parameter na alpha. So, yun din yung gagamitin natin. Note na yung alpha, okay, is defined with respect to the positive x-axis. Okay? So, parating ganun yung definition natin ng direction. Okay. So, now let's consider this example. So a robot vehicle or rover, okay, is exploring the surface of Mars. The stationary Mars lander is the origin of coordinates, and the surrounding Martian surface lies in the XY plane. Okay? The rover, which we represent as a point, has X and Y coordinates that vary with time. So ito na yung expressions, yan na yung expressions for the X and Y coordinates, okay, nung rover. So letter A, find the rover's coordinates and distance from the lander at t equals 2 seconds. Okay. Letter B, find the rover's displacement and average velocity vectors for the interval t equals 0.0 seconds. And letter 2, t equals 2 seconds. And letter C, find the general expression for the rover's instantaneous velocity vector and express it at 2 seconds in component form and in terms of magnitude and direction. Okay, so we always begin with what we know. And ang alam natin ngayon is that ito yung ating expressions for the x and y coordinates. Okay, so yan yung ating expressions for the x and y coordinates. Okay, so we want to find yung tawag dito coordinates after 2 seconds. So ang gagawin natin is we use your expression. So for letter A, we use your expression for x, which is equal to 2 meters minus 0.25 meters per second squared times 2 seconds squared. This will give us 1 meter. And then for y, which is 1.0 meters per second times t minus or plus 0.025 meters per second cube times 2 second cube, and this gives us 2.2 meters. Okay, so yan na yung coordinates after 2 seconds, okay, nung rover. Okay, so nag-travel na siya ng 1 meter along the x-axis and nag-travel siya ng 2.2 meters along the y-axis. Okay, ano yung next question? So letter B, find the rover's displacement and average velocity vectors for the interval 2 equals 0.0 seconds and 2 equals 2.0 seconds. So nakuha na natin yung displacement niya o yung position niya at t equals 2 seconds. So sa letter B, so this is at t equals 2 seconds. So at t equals 0 seconds, ang position niya ay 2 meters. Okay, kasi magiging 0 lang yan, di ba? And then ito magiging 0, ito magiging 0. So yung position niya is 0.0 meters. Okay, at 0 seconds. Okay, then ang pinapahanap dito is the rover's displacement and average velocity. Okay, so now we write this in terms of yung position vector. Okay, so yung position, okay, at t equals 0.0 seconds. So that's let's say that's R1. So x equals 2.0 meters I hat plus 0.0 meters j hat. And then yung position at t equals 2 seconds, that's R2 equals 1.0 meters I hat plus 2.2 meters j hat. So ibig sabihin ang kanyang displacement is given by R2 minus R1. So this becomes 1.0 meters I hat plus 2.2 meters j hat minus 2.0 meters I hat. Okay. Or this is equal to negative 1.0 meters I hat plus 2.2 meters j hat. Okay, so ang nangyari is yung rover nag-move ng 1 unit towards the negative x-axis. Okay, and after 2 seconds, and then so parang nag-move siya towards the left. We consider an axis na ganito, di ba? Positive x, positive y. So nag-move yung rover towards the left ng 1 unit. Okay, okay, so let's just do that. Ituhin na natin. So if we have this coordinate system, okay, and yung position niya was 2 meters. So let's say this is 1, 2. So ito yung position na R1. Okay. So ito yung unit vector na R1. Okay. Yan yung unit vector na R1. Okay. And R2 is 1 meter at saka 2.2 meters. So let's say this is 1 and then this is 2. So somewhere here yung 2.2 meters. So nandyan yung yung rover at after 2 seconds, and then ito ngayon yung R2. Okay. So yung R2 minus R1 or yung displacement is this. Okay, so yan yung delta R equals R2 minus R1. Okay. So nag-move siya 1 unit towards the left kasi negative, and then 2.2 units na upward. Okay. Yan yung naging motion ng rover. Okay. Okay, so now, ang next na pinapahanap is yung average velocity. So yung average velocity vector is defined as delta R over delta T. We already know what delta R is. Ang delta R is negative 1.0 meters I hat plus 2.2 meters j hat. And then yung delta T is 2.0 seconds minus 0.0 seconds. So this gives us negative 0.5 meters per second I hat plus 1.1 meters per second j hat. Okay, so ito yung ating average velocity na vector. Okay, then so yan yung ang sabi dito is find the general expression for the rover's instantaneous velocity vector v. Okay, so sa letter C, we are supposed to find a general expression for the rover's instantaneous velocity vector v. So we begin with yung position vector. The position vector is xi hat plus y j hat. Okay, bakit tayo dyan nagsisimula? Kasi we know that the instantaneous velocity vector is nothing but the derivative of the position vector with respect to time, and that's equal to the derivative of the components of the position vector with respect to time. So ito yung derivative ng kanilang mga components. Okay, so we know kung ano yung dx dt. We know kung ano yung x, I mean. So ang x is 2 meters minus 0.25 meters per second. squared, and yung y is 1.0 meters per second t plus 0.025 meters per second squared per second cube t cube. Okay, and if we take the derivative of x with respect to time, we'll end up with negative. So 2 times 0.25, 0.5 meters per second squared times t. Okay, and then yung dy dt naman is 1.0 meters per second plus, and then 3 times 0.025, so that's 0.075 meters per second cube t squared. Okay, so yung instantaneous velocity vector natin is then given as negative 0.5 meters per second squared I hat plus 1.1.0 meters per second plus 0.075 meters per second cube t cube j hat. Okay, so okay, now at t equals 2 seconds, ano yung velocity vector? So t equals 2 seconds, so yung component along the x-axis doesn't change. Yung bakit may squared yan? Hindi yan dapat may squared. Yeah. Okay, so it's still the same. And then at t equals 2 seconds, yung y component magbabago. Kasi i-multiply natin itong 0.075 meters per second cube by 2.0 second cube okay, j hat. So yung velocity vector natin ngayon is given by wait, t pala to, no? T. May t. So dapat meron ditong 2 seconds. Okay. So dapat may 2 seconds yun. So this is given by 1.0 meters per second I hat, okay, plus 1.3 meters per second, okay, j hat. Okay, yan yung velocity vector in component form. In magnitude, we have negative 1.0 meters per second squared plus 1.3 meters per second squared. And we take the square root of that. We get 1.6 meters per second. And in terms of direction, we have theta equal to tangent inverse ng 1.3 meters per second divided by negative 1.0 meters per second. Then this gives us negative 52 degrees. So let's check. Yung x component is negative. Okay, yung y component is positive, which means na ito ay nasa, tawag dito, ito ay nasa second quadrant. Okay, so itong angle na ito ay nasa fourth quadrant. So we need to add 180 degrees. So yung correct direction ngayon will be 128 degrees, okay, with respect to the positive x-axis. Okay. Okay, so yan yung problem na yan. Okay, now let's see. Ano bang nangyayari sa rover? So originally, yung kanyang position, yung at t equals 0 seconds, nandito siya. Okay, and then at 2 seconds, nandun siya. And then dito, sa calculations, dinagdag yung 1 second. Makikita natin na yung velocity niya, Okay, so if we trace this, okay, connect the dots and trace the path. So ito yung tangent line, yung kulay green yan yung tangent line at the original position, okay, at t equals 0.0 seconds. Itong tangent line na v1 is yung velocity vector at t equals 1.0 seconds, and then yung tangent line at t equals at position r2, okay, ay yan yung velocity vector niya at t equals 2 seconds. So makikita natin na nag-i-increase yung velocity tawag dito nung particle, okay, after some time, okay, after 2 seconds, okay. And then pero nagmo-move siya towards the negative x-axis, nagmo-move din siya towards the positive y-axis, pero yung magnitude ng velocity, okay, ay nag-i-increase from 0 to 2 seconds. Kung titignan din natin yung direction, okay, at t equals 0 seconds, okay, so makikita natin na yung position niya ay at 0 and 2 meters, okay, and yung velocity vector dito, kung titignan natin, okay, so yung velocity vector, so at t equals 0, this will become 0, so wala kang component, okay, walang component yung x, tawag dito yung x, yung x component ng, or 0 yung x component ng velocity at t equals 0 seconds. Okay, on the other hand, yung y component ng velocity at t equals 0 seconds is equal to 1.0 meters per second. Okay, so this corresponds ngayon to 1.0 meters per second. Okay, and ito naman ngayon corresponds to ano na ngayon na-compute natin, 1.6 meters per second. So nag-increase yung velocity from 1 meter per second to 1.6 meter per second. Tapos nagbago yung direction niya. Okay. Yung direction nito, since dy has a constant value 1.0 meters per second, and then dx ay 0. So if you take the tangent inverse of that corresponds to 90 degrees. Okay, kaya makikita niyo dito yung direction is 90 degrees. Okay? Okay. So I hope clear yan. Again, kung meron kayong questions, just take a screenshot and send me an email, and explain nyo kung ano yung hindi nyo naintindihan. Okay. So now let's move to how acceleration is defined. Okay. So pag-usapan naman natin yung acceleration vector. Now, yung form, at least mathematically, no acceleration, average acceleration is the same as kapag one dimension. Okay, so the average acceleration is given by delta v over delta t, or v2 minus v1 na vector, where v2 and v1 ay yung final and initial vectors respectively, initial velocity vectors respectively. So halimbawa kung yung kotse ay nagta-travel from position P1 to position P2, okay, so at position P1, yan yung kanyang velocity, and then yung position P2, at position P2, ito yung kanyang velocity. Okay, to get V2 minus V1, we can do that graphically, di ba? So ito yung V2, ito naman yung V1, and then since we are subtracting V1 from V2, we connect delta V is defined as the direction from V1 to V2. Okay, so yun yung direction ng delta V or ng change in velocity. If you divide it by time, okay, then you get the average velocity. So itong kulay orange na arrow na yan represents the average velocity vector. Okay? Hindi sila necessarily magkapareho ng magnitude sa delta V, no? Kasi yung delta T is not necessarily equal to 1. So if delta T is less than 1, then your average velocity vector will be longer than delta V. And yun naman yung mangyayari dito kasi typically, to get the instantaneous velocity, we will set delta T, or we let delta T approach 0, right? Okay, so, and yun na yung susunod natin actually i-discuss. Ano naman yung instantaneous acceleration? So yung instantaneous acceleration, A is defined as the limit of the average velocity vector as delta T approaches 0, or the limit as delta T approaches 0 ng delta V over delta T, or okay, this is just a derivative with respect to time of the instantaneous velocity vector. Okay. So, anong mangyayari dito ngayon? So, basically, if you have this V1 vector and then V2 vector, okay, kung dilutong mo yung V2 vector dito, okay, tama ba yung ano? Mukhang hindi sila parallel. Okay, so if we are going to, yan, so mukhang parallel and pareho ng length. So, yan yung V2, then ito ngayon yung delta V. Okay, and if we use a time interval, if we let delta T approach 0, then we expect yung acceleration vector to be, tawag dito, quite, well, to be at least longer than delta V. Ito yung na yung nakikita natin dito. So yung acceleration vector in this case, okay, is defined as the limit as delta T approaches 0 of delta V over delta V. Okay, if the tawag dito, if the acceleration is along a straight line, then this is straightforward kasi kukunin nyo lang naman yung difference between V2 tsaka V1, difference in length, at yung difference in length nila ay ito, delta V. Then you can also get the acceleration vector by using this definition. Okay, so anong mapapansin natin dito? Anong magiging conclusion din natin dito? When do we have acceleration? So we have acceleration if there's a change in the velocities, and we also have acceleration, okay, if there's a change in direction. Hence, when the velocity changes or when the direction changes. Okay, so acceleration, you get acceleration if the velocity changes or if the direction also changes. Okay. Okay, so now we have, tawag dito, now we can define yung acceleration vector in terms of its components. Okay, since A is equal to dv dt, then if you take the derivative of the velocity vector, we have vxi hat plus vy j hat plus vz k hat. Okay, so yung acceleration, instantaneous acceleration vector ngayon will be given by b vx dt I hat plus d vy dt j hat plus d bz dt k hat. So this is nothing but a sub x I hat plus a sub y j hat plus a sub z k hat. So a sub x is equal to dvx dt, okay, and then a sub y is equal to dvy dt, and a sub z is equal to dvz dt. And since yung vx is the derivative of the position along the x-axis, then a sub x is just the second derivative with respect to time of x. A sub y is also the second derivative with respect to time of y, and a sub z is just the second derivative with respect to time of z. Okay, so you can also write the position acceleration vector in terms of the position vector as d squared dt squared x I hat plus d squared dt squared y j hat plus d squared dt squared z k hat. Okay, so yun yung para sa acceleration. Okay, as an example, we continue with tawag dito, with the example on the rover, diba? The Mars rover specifically. Okay, so ang pinapahanap dito is are the components of the average acceleration for the interval t equals 0.0 seconds to t equals 2 seconds, and find the instantaneous acceleration at t equals 2 seconds. Okay, so alam natin na yung Vx, okay, na-compute na natin to kanina, is equal to negative 0.05. Okay, negative 0.5 meters per second squared times t, and yung Vy is equal to 1.0 meters per second plus 0.75 meters per second cube t squared. Okay, so at t equals 0, to get yung components of the average acceleration for the interval t equals 0 to t equals 2 seconds, so kunin muna natin yung velocity vector at t equals 0.0 seconds. So the velocity vector, sabihin natin v naught yan. Okay, ay equals sa at 0, so 0 yung x, di ba? I hat plus, and then 1.0 meters per second j hat, di ba? Kasi 0 ito, then 0 yan. So we're left with 0 for the x component and then 1 meters per second for the y component. Then at t equals 2 seconds, then we have v2 is equal to, so 2 times a negative 0.5, we have negative 1.0 meters per second I hat plus 1.3 meters per second. So na-compute na natin lahat to kanina. Okay, so yung average velocity natin ngayon, okay, from t equals 0 to t equals 2 seconds. Okay, so yung average velocity is equal to v2 minus v naught divided by delta t. So that's negative 1.0 meters per second, okay, minus 0, okay, I hat, okay, plus kalimutan ko yung j hat dito. 1.3 meters per second minus 1.0 meters per second, okay, j hat, so that's 0.3 meters per second j hat, and delta t is 2 seconds minus 0.0 seconds. So the average velocity is negative 0.50 meters per second squared I hat, okay, plus 0.15 meters per second squared, okay, j hat. So along the x-axis, yung average velocity is negative 0.50 meters per second squared, and along the y-axis, yung average velocity is 0.15. Wait. From 0.3 minus 1, so that's 0.3. Okay, sandali ah. Okay, so yep, this is correct. Okay, so sa letter, so ito yung letter A. Okay, yung A sinasolve natin. Letter B, find the instantaneous acceleration at t equals 2 seconds. Okay, so the instantaneous acceleration is computed from dvx dt I hat plus dvy dt j hat. Now, Vx has this expression. So, yung derivative ng Vx with respect to time is negative 0.50 meters per second squared. And then yung Vy has this expression. So, yung derivative with respect to time ng Vy is 0.15 meters per second cube times t. Okay, so yung acceleration vector natin, instantaneous acceleration vector is negative 0.5 meters per second squared plus 0.15 meters per second cube times t. So I hat and then j hat. And then at 2 seconds, so at t equals 2.0 seconds, you have the instantaneous velocity vector to be negative 0.50 meters per second squared I hat plus 0.30 meters per second squared j hat. Okay, kasi multiply ko na yung 2 by tawag dito, by 0.15. And then remember na itong t na ito has a unit of seconds, so kakancel siya with the 1, with the second cube dun sa denominator. Okay, so yung components ng instantaneous velocity vector ay negative 0.5 meters per second squared, and along the y-axis, it's 0.3 meters per second squared. Yung magnitude nito ngayon, okay, is given by square root ng negative 0.50 meters per second squared plus 0.30 meters squared per second squared. Okay, and this is equal to 0.58 meters per second squared. Tapos yung direction is nothing but tangent inverse ng 0.3 meters per second squared divided by negative 0.5 meters per second squared. Okay, this gives us a calculator to lead to negative 31 degrees na angle. But pansinin nyo na yung x-axis is negative and yung y component is positive. So, ibig sabihin nasa second quadrant siya. And yung angle na to is a fourth quadrant. So, we need to add 180 degrees. So, yung direction is actually 149 degrees with respect to the positive x-axis. Okay. So, and yun nga yung makikita natin dito sa figure. Okay, so makikita natin na yung acceleration vector, okay, na A2 is or has an angle of 149 degrees with the positive x-axis, and yung magnitude niya is 0.58 meters per second. Okay, at t equals 0, okay, pag t equals 0, ang acceleration vector ay may x component lang kasi this becomes 0, diba? At t equals 0 seconds. So, x component lang meron. Kaya dito makikita nyo negative 0.5 lang yung acceleration vector. Okay? And then at t equals 1, magkakaroon na siya ng y component. Okay? Kasi nag-i-increase na yung velocity along the y-axis. Okay, so kaya umangat ng konti yung direction dito kasi meron siyang y component dyan. Ito naman yung x component niya. Okay, ang x component ay hindi nagbabago pa nating 1, tawag dito, 0.5 kasi wala, di ba, walang time dependence, di ba? So constant yung acceleration along the x-axis. So parati itong negative 0.5 meters per second. Okay. Ito ay negative 0.5 meters per second squared. Tapos ito yung x component niya rin dito is negative 0.5 meters per second squared. Pero yung y component niya ay nag-increase na. So 0 yung y component dito, dito nag-increase, and then dito yung y component ay equal sa 0.30 meters per second squared. Okay, so yan yung para sa acceleration vector. Okay, now nakita natin dito na yung acceleration vectors can have components, x and y components. But they don't necessarily have to be along the x and y axis. Depende rin kung ano yung tinitignan natin na system. Okay? Okay, now, if a particle, okay, is going along a curved path, okay, tulad ng nakikita nyo rito, okay, yung velocity niya at some point p, okay, is, tulad ng paulit-ulit natin sinasabi, is the tangent line, okay, at that point. Okay, so at point P, okay, yung velocity niya is tangent, okay, to the path at point P. Now, yung acceleration vector is not necessarily perpendicular dun sa velocity vector. Tulad ng nakikita nyo rito sa figure. Okay, so magde-depend actually yan sa change in velocity. Okay, from one point to another. Okay, di-describe natin yan mamaya-mayang konti. So, itong acceleration vector na ito has two components. One component that is parallel to the velocity vector or parallel to the tangent line at point P, and another component which is perpendicular, okay, to the tangent line at point P, or perpendicular to the velocity vector at point P. Okay? Binabanggit natin to kasi magiging importante to later sa circular motion. When we discuss circular motion, magiging significant ito. Okay, if the object, ang tawag dito, if the particle doesn't change in direction, then of course you expect that the acceleration has the same direction as the change in velocity. Pero pag nagbago siya ng direction, tulad dito, nagbago yung direction from V1 to V2, ito ngayon yung delta V, the acceleration vector is also in the same direction as the change in velocity. Okay? So this explains yung, this exhibits yung change in direction, this exhibits yung change in, tawag dito, change in the velocity. Okay. Okay, now, bakit ka nagkakaroon ng acceleration which is, tawag dito, which has two components? Bakit hindi pwedeng acceleration ay towards ano lang, the perpendicular component or towards the parallel component lang? Well, the reason for that is that yung change kasi ng velocity dictates kung magkakaroon siya ng perpendicular components. Okay? So in this, dito sa unang figure, okay, you have a velocity vector. Okay? Well, you have a motion, okay, na kung saan yung speed ay constant. So if the speed is constant, so hindi nagbabago yung velocity vector. Okay, ang nagbabago lang sa kanya is yung direction. I mean, yung magnitude ng velocity vector is still the same. And if the magnitude of the velocity vector is still the same, so kidudugtong natin yung velocity vector dito, okay, then you get an acceleration, okay, which is perpendicular, okay, to, sorry, this is delta V. Okay, and then you get an acceleration which is the same direction as delta V, at yung acceleration na yan is perpendicular dun sa normal line, okay, at point P. Now, when do you get an acceleration? Okay, that is tawag dito, ahead of the normal. So ito yung normal line, ano? Then yung acceleration yan is ahead. Well, you get that if the particle increases in speed. Okay, kasi pag nag-increase ng speed, maghahaba yung velocity vector. Okay, and then if we draw the velocity vector here, okay, then we have delta V. Okay, we have a delta V which is in this, oops, sumobra yata. Delta V which is in this direction. Okay, so let me just redraw that. Okay, delta V which is in this direction. Okay, yan yung delta V natin. Okay, which is, so your acceleration ngayon will have the same direction as delta V. On the other hand, so dito, no, nag-increase yung kanyang, well, nag-increase yung kanyang speed. Okay, increase. Ito naman, kapag nag-decrease yung speed, okay, yung velocity vector, then you get, so nabawa, dito na yung nag-decrease yung kanyang speed. Okay, then you get okay, something like that. Okay, you get an acceleration which is this. Okay, so yan yung delta V. Okay, same direction as itong delta A. Okay, so if you see an acceleration or if the object is increasing in velocity, then the acceleration vector is ahead of the normal line. Pero kung yung velocity vector is, ang tawag dito, decreasing, okay, then yung acceleration vector is behind the normal line. Okay, so that's one way to interpret yung motion ng particle. Okay, so let's consider that dito sa example na ito. We have a skier that is moving along a ski jump ramp according to the figure. Okay, itong figure na ito. The ramp is straight from point A to point C and curved from point C onward. Okay, the skier speeds up as he moves downhill from point A to point E. So nagsi-speed up siya from here to here. Okay, where her speed is maximum. Okay, she slows down after passing point E. Draw the direction of the acceleration vector at each of the points B, D, E, and F. Okay, so at point B, okay, point B, so ito yung, at point A, ganyan, for example, yung kanyang velocity. Then at point B, nag-increase yung kanyang velocity. So yung difference nitong dalawa na ito, okay, since pareho naman silang parallel, or parallel sila sa isa't isa, sorry. Okay, yung difference nilang dalawa is in the same direction, okay, as both vectors. Okay, so yung acceleration vector will be parallel to both B and A. So yun yung nakikita natin dito. Okay. Okay. Now at point C, nag-increase din siya further. Okay, ganun pa rin. Okay. Same direction pa rin siya. Okay, hindi pa nagto-turn. So ibig sabihin yung acceleration vector is also in the same direction as the acceleration vector at point B. Now at point D, nag-turn na siya. Okay. And dahil nag-turn siya at the same time, nag-increase pa yung kanyang speed. So ibig sabihin, the acceleration vector is in front of the normal line. So if this is the normal line, okay, yung acceleration vector ngayon is in front of that. Okay, kasi remember yung direction of motion ay paganyan, diba? So nasa harap ng normal line yung velocity vector. Now at point E, okay, dito, yan na yung maximum na tawag dito, maximum na speed. Okay, so ibig sabihin, mag-change na rin siya ng direction, mag-change na rin ng ng tawag dito ng speed, babagal na yung speed. So at that point, okay, yung velocity vector will be pointing towards or along the parallel line. Now dito, from point E to F, mabagal na yung kanyang speed. So, ibig sabihin yung acceleration vector will be behind the normal line. Kung ito yung normal line, then ito yung acceleration vector. Okay? So, yan yung nangyayari dun sa acceleration vectors for this particular example. Okay. So, I hope klaro sa inyo yung ano na yan, yung tawag dito, definitions natin ng position vector, velocity vector, acceleration vector, average velocity vector, tsaka average acceleration vectors. So, in essence, parang i-inform, parang pareho lang sila naman dun sa ano, sa one-dimensional motion. Pero pagdating sa 2D tsaka sa 3D, nagkaroon lang tayo ng components along the x-axis, y-axis, tsaka z-axis. Now we apply yung concepts na yon dun sa ating next na ano, sa isang pinaka-common na tawag dito. Example, sobrang common ito kasi, di ba, pag nagbato tayo ng object, it undergoes this type of motion. Okay, bato tayo ng object, kahit anong object pa yan, okay, it has the same type of motion. So, kung magbabato nga tayo ng object, anong nakikita natin na motion niya? So, nakikita natin yung motion niya is this. Okay, so itong yan. Okay, so curved yung kanyang motion. Now, if tawag dito, tignan natin yung trajectory niya, yung path na tinitake niya at the same time intervals. Okay, so at the same time intervals, okay, we will see, okay, na ganito yung nangyayari along the y-axis. So parang nag-i-increase, diba, nag-i-increase yung kanyang position. Okay, at the same time intervals. Pero kung titignan nyo rito along the x-axis, pare-pareho lang yung kanyang, well, hindi maganda yung pagdadawin ko, pero pare-pareho lang yung ano niya, yung, anong tawag dito? Yung displacement, okay, along the x-axis. Okay, so this type of motion is called projectile motion. And yung object, okay, na binabato nyo, okay, is a projectile. Okay. Now, what is a projectile motion? Okay. Paano natin alam if a projectile is moving tawag dito in this fashion? How do we know na projectile motion yung tinitignan natin? So, basically, a projectile motion experiences is an object that experiences only the force due to gravity. So isang force lang yung nararamdaman nung projectile, okay, for the motion to be called projectile motion. Okay? At yung force na yun is gravity, which means na ang acceleration, okay, is equal to negative 9.8 meters per second. Ang acceleration along the y-axis ng projectile ay negative g or negative 9.8 meters per second squared. Okay, bakit along the y-axis? Kasi yung gravity, di ba, nag-work lang naman yan towards the or along the vertical. Okay, wala kang acceleration along the x-axis. May nakita na ba kayo na nalaglag na bola horizontally? Wala, di ba? So if we use this type of coordinate system, okay, then we say na yung object only experiences, tawag dito, gravitational forces along the y-axis. So yung acceleration, so meron lang siya acceleration along the y-axis. Walang nalalaglag na object horizontally, so walang tawag dito, walang acceleration along the y-axis. Okay? So yan yung Yan yung nakasulat dito ngayon. Okay? Okay? 0 yung acceleration along the x-axis and negative g yung acceleration along the y-axis. Okay? If an object experiences that type of acceleration, then you call the motion of that object as projectile motion. Now, yung trajectory ng object na yan is parabolic. Okay? So, yung kanyang path na ito take is parabolic. Yun din yung nakikita natin dito sa figure na ito. Okay? Parabola yung kanyang motion. Okay? Okay. So, paano natin alam na parabolic yung motion niya? Well, before we go into that, let's consider muna yung mga equations of motion, kinematic equations na diniscuss natin before. Okay, ano ba yung mga tawag dito? Kinematic equations. So, along the x-axis, okay, we have x equals x naught plus v naught x t plus 1/2 ax t squared. Pero since ax is 0, okay, and then we typically set x naught to be 0 naman. Pero sige, wag muna natin iset yan na ganyan. Ibig sabihin, ang x is equal to x naught plus v naught x t. Okay, so yun yung una. Pangalawa is v x is equal to v naught x plus a sub x t. Again, since ax is 0, then vx is equal to v naught x t. Now, this is an important result kasi ang sinasabi nito, speed is constant. Of course, the speed is constant kasi wala kayong acceleration. So along the x-axis, the speed is constant. Okay, the velocity is constant. There's no change in direction and there's no change in speed. Okay, now along the y-axis, okay, meron pang dalawang equations, no? Pero if you apply yung concepts ng acceleration dun sa dalawang equations, you'll end up with these two equations anyway. Okay. So now along the y-axis, we have y is equal to y naught plus v naught y t. Okay. And then papalitan natin yung ay ng negative g. Minus 1/2, minus 1/2 g t squared. And yung velocity naman along the y-axis is v naught y minus gt squared. And we obtain that by replacing ay with negative g. Okay, so again, lahat ng mga equations na ito assumes na ito yung coordinate system na sinusunod natin. Okay, so positive y upward means acceleration due to gravity is pointing downward. Okay. Okay. So, bakit nga anong tawag dito? Bakit nga parabolic? Well, let's consider this figure. Okay. So, let's begin with yung object at the origin. Okay, yung object na yan has an initial velocity v naught. Okay, meron siyang initial velocity v naught. Okay, and yung direction niya is alpha naught. Okay, v naught and then alpha naught. So yung v naught na yan ay may components along the x tsaka along the y axis. So binrake down natin yung v naught into its x and y components. Okay, so ito yun para sa x component, and ito yun para sa y component. Okay, at a certain time interval, okay, remember na along the x-axis, hindi nagbabago yung velocity. So yung v naught x will have the same velocity at the next time interval. It will also have same velocity at the succeeding time intervals. Kasi nga hindi nagbabago, di ba? Okay, so pare-pareho yung velocities niya at each time interval. On the other hand, along the y-axis, we begin with this velocity. Pagdating niya dun sa isang time interval, okay, babagal yung kanyang velocity. Bakit babagal yung velocity niya? Kasi yung object na yan ay hinihila, okay, nung gravity. Okay, if an object is being pulled downward, pero yung initial motion niya is upward, syempre babagal yung kanyang speed. So what you can also see here is that if the acceleration and the velocities are in opposite direction, then you expect the velocities to decrease. Pero kung yung acceleration at saka yung velocities are in the same direction, then you expect the velocity to increase. Okay, so dito nakita natin na yung velocity at the next time interval ay bumagal kasi yung acceleration ay in opposite direction dun sa motion ng particle. Okay, at pag kinuha niyo yung magnitude ng components na yan, you get this velocity. Now, at the topmost point, walang velocity along the y-axis. Meron ka pa ring velocity along the x-axis kasi nga hindi nagbabago yung velocities horizontally dahil walang acceleration. Okay, so meron ka pa ring velocity along the at the topmost point, and its only component is along the x-axis. So wala siyang y component. Now, from the topmost point, dun sa susunod na time interval, syempre malalaglag na yung object. Diba? So, magkakaroon siya ngayon ng velocity which points downward in the same direction as the acceleration. At dahil, tawag dito, same direction na yung velocity at saka yung acceleration, mag-i-increase na lang yung kanyang speed. Okay? So, mag-i-increase yung speed, mag-i-increase yung acceleration, okay, and kakaroon ngayon ng components, okay, na ganyan. Okay? Yung velocity. Okay, pagtatama niya sa ground. Now, it turns out na yung component na ito, okay, if they are in the same level, so same level to, no? Okay. So this will have a velocity v naught, pero yung components niya will be of course v naught x pa rin yan, pareho dito. Okay. Pero tas ito naman negative v naught y. Okay, so opposite in direction dito. So this is negative v naught y. So v for y is just negative v naught y at the same level. Okay, so ibig sabihin nasa fourth quadrant, di ba? Kasi positive yung x, negative yung y. So nasa fourth quadrant yung angle. So itong angle na to ngayon will be negative alpha naught. Okay, so opposite ng angle dun sa initial na position niya. Now, balik tayo sa question. Paano naging parabolic? Ngayon, kung iti-trace nyo yung path, okay, ng object, okay, from here to here, to here, there, and there, okay, makikita nyo na pag kinonect niyan, ang path na yan has a parabolic shape. Okay, kaya parabolic yung shape niya kasi nagbabago yung velocities along the y-axis at constant yung velocities along the x-axis. Okay, kung hindi nagbabago yung velocities along the y-axis, kung constant yung velocity along the y-axis, the object will just go in a straight line. Kung nagbabago yung velocity along the y-axis at nag-i-increase, yung velocity ay will be parabolic pa rin pero pataas, curving upward. Okay, which is yung nangyayari naman dito. Okay, dito nag-i-increase yung velocities. So it's curving. Nag-i-increase yung velocities pababa. So it's curving downward. So parabolic pa rin yung yung motion niya. Okay? So, again, kaya parabola yan kasi one axis changes in velocity and the other axis does not change in velocity. So, from here as well, from this figure, pwede na rin natin i-define kung ano yung x and y components ng velocity. So, nakita natin na yung v naught x is the x component of the initial velocity. So, v naught x is nothing but v naught times cosine ng alpha naught. And then yung v naught y is the y component of the initial velocity. So, this is v naught times sine alpha naught. Okay, so now we have these equations on top of itong kinematic na equations. So with that, pwede na tayo mag-solve ng problems involving projectile motion. Okay, now just for completion, of course, syempre, minsan pinapahanap is yung position. So you get yung magnitude ng position. The same way, x squared plus y squared, the same way na ginagawa natin before, magnitude ng velocities as vx squared plus vy squared, and then square root. Ito is tangent inverse ng y over x. This is, ano bang ginamit natin ng alpha? Okay. Alpha is the tangent inverse of vy over vx. Okay, and ano pa? Yeah, okay. So ganyan yung expressions, ibang expressions na ginagamit natin to solve for specific tawag dito, parameters or variables. Okay. So yeah, that's that. Okay. So this figure just demonstrates kung paano na-solve kung paano na-compute yung yung components ng initial velocity. Okay. Oops, cosine, and this is sine alpha naught. Okay. Yan at saka. Okay, so it's nothing but trigonometry. So ito yung right triangle ninyo. This is the tawag dito. This is the if this is the angle, then this is the opposite, and this is the adjacent side, and this is the hypotenuse. Okay. So ganun lang. Okay, let's see. Let's try to solve this problem. Okay, so a physics book slides off a horizontal tabletop with a speed of 1.10 meters per second. It strikes the floor in 0.480 seconds. Ignore a resistance. Find the height. Find A, the height of the tabletop above the floor. A letter B, the horizontal distance from the edge of the table to the point where the book strikes the floor. Letter C, the horizontal and vertical components of the book's velocity. And letter D, just before it reaches the floor, and the magnitude and direction of its velocity just before it reaches the floor. And letter D, draw xt, yt, vxt, and vyt graphs for the motion. Okay, so again, saan tayo magsisimula? With what we know. So what do we know? Okay? Well, una muna natin gagawin, okay, una sa mga isa nating alam is how the book behaves. Okay, so let's draw a table. Okay, yan yung table. Ito yung paano ng table. Okay, and then meron kang book dyan. Okay, so ito yung book. Okay, and then it slides off a horizontal tabletop. So ibig sabihin, pag sinlide mo siya, diba yung initial na motion niya, yung unang motion niya, okay, is horizontal. Right? Diba kasi nagsislide off lang siya. So it slides off horizontally. Okay. Isa yun sa mga alam natin. So anong implication nito ngayon? Ang initial velocity niya is the same as the x component kasi horizontal lang yung kanyang motion. Which means na yung speed na ito, yung speed na yan, okay, is just the velocity along the x-axis. Yan yung initial velocity niya. It also means okay, na ang velocity along the y-axis, yung initial velocity along the y-axis is 0. Okay, kasi okay, horizontally sliding off. It slid off horizontally. Okay. So ito yung mga bagay na anong tawag dito, hindi obvious. Pero kailangan yung anong tawag dito, ma-figure out based dun sa given. Okay, so nakasulat. And yan din yung physics. So, 'di ba? So the book slides horizontally. Ang implication niya in terms of physics is that wala siyang y component ng initial velocity. Meron lang siyang x component ng velocity. Then, of course, malalaglag yung book na yan. It will have a parabolic trajectory. Okay, paano natin alam na parabolic yung trajectory niya? As it is falling, ano yung force na experience niya? Bakit siya nalalaglag in the first place? Kasi merong gravity. As it is falling, meron pa ba siyang ibang force na naramdaman? Sabi dito sa problem, ignore a resistance. So wala na siyang ibang force na naramdaman. So ibig sabihin itong book na ito undergoes a projectile motion. Okay? Kasi it only experiences gravitational force. So from here, okay, which is at time t equals 0, i-assign na natin yan at time t equals 0 to here, which is at time t equals 0.480 seconds, okay, just when it reaches the floor. Okay, yung trajectory ng object is parabolic. Okay? Okay. So, yan yung isa pang given. Yung time it took para tumama yung book sa floor. So, almost half a second. So, pinapahanap natin dito ngayon yung tawag dito. Yung ang tawag dito. Pinapahanap yung height. Okay. Okay. So, anong gagawin natin dito ngayon? Ano pa ba yung alam natin? Siyempre, mag-a-assign na tayo ng coordinate system. Okay. Paano natin i-assign ng coordinate system? Put the origin at the position where the time starts. Dito nagsimula yung motion. Lagay mo ngayon yung Cartesian coordinate system mo dyan. Okay. Masyado yatang mahaba, no? Okay. Okay, so dyan natin lalagay yung Cartesian coordinate system. Positive x and then positive y. Okay, dinefine ko yung positive y as upward and dinefine ko yung positive x as going towards as having a direction towards the right. Okay, so ang ibig sabihin nito is that yung acceleration along the y-axis is negative g or negative 9.8 meters per second squared. Okay. And since this is projectile motion, so yung acceleration is also along the x-axis is also equal to 0. Okay, so meron pa ba tayong nakalimutan? Okay. So yan, yan na yung lahat ng alam natin based on the given. So let's start. Letter A, height of the tabletop above the floor. Ang alam natin dito is merong time, merong velocities, and then merong, ang pinapanap is height. Okay. By the way, if we put the origin at the initial, okay, at this initial position, so ibig sabihin initial position is has coordinates 0, 0. Okay. So we use this equation y equals y naught plus v naught y t minus 1/2 gt squared. Okay. So anong makukuha natin dito ngayon? So if we put the given 0 plus v naught y is 0, okay, times t minus 1/2 times 9.8 meters per second squared times 0.480 second squared. So yung y ngayon is negative 1.13 meters. Okay? Negative 1.13 meters. So anong ibig sabihin yan? If this is the origin, negative yung position. So ibig sabihin, below the origin yung kanyang. So itong height na to, that's negative 1.13 meters. Yung height na yan. Okay? Letter B. So, of course, kung ang tinatanong lang ang height, so the height is 1.13 meters. Now, does this make sense? Siyempre, isipin nyo, gaano ba kataas ang 1.13 meters? So, sabi natin, estimate natin yung isang arm is, isang arm is about 1 meter. So, dagdag kayo ng 10% ng length ng arm ninyo, ganun nakataas yung table. Yung bang length ng typical, height ng typical table? Yes, that's about correct height. Okay, so sa letter B, ang pinapahanap is the horizontal distance from the edge of the table to the point where the book strikes the floor. So, horizontal distance from the edge of the table, okay, so dito, halimbawa dyan siya nalaglag. Okay, well, hindi ko sinabi na nalaglag siya from the edge, no? Okay, to the point where the book strikes the floor. So itong point. So pinapahanap is actually this distance. Okay, so alam natin na pag projectile motion, if the object is undergoing projectile motion, then this is the expression for the displacement. Okay, so this is equal to 0 plus v naught x. Okay, so positive siya kasi dinefine natin yung positive x to be along the to be along the right, in the direction na right, okay, pointing to the right. So 1.10 meters per second, and then time is 0.480 meters. Oh, sorry, seconds. Okay, so ang x ngayon is 0.528 meters. Okay. So that's about half a meter. Letter C. Ano yung horizontal and vertical components of the book's velocity? Okay, just before the book reaches the floor. So at this point, just before it hits the floor, ano yung horizontal and vertical components ng velocity ng book? Okay, so alam natin pag projectile motion, Vx is just equal to V naught x. So ibig sabihin, hindi nagbabago, di ba, yung velocities niya along the x-axis. Okay, and then along the y-axis, we have this expression V naught y minus g times t. Okay, pero yung V naught y, initial velocity is 0. So this is 0 minus 9.8 meters per second squared times 0.480 seconds. So ang Vy is equal to negative 4.70 meters per second. So at this point, meron kang velocity na 1.10 meters per second, and then velocity na negative 4.7 meters per second. Okay, so yan yung components ng velocity. Okay, so approximately, yan yung difference in lengths. Okay. Then, ang susunod na pinapahanap is magnitude and direction of its velocity. So yung magnitude is just given by Vx squared plus Vy squared, then you take the square root of that. So that's equal to 4.83 meters per second. Ito ngayon yung 4.83 meters per second. Okay. So yan yung V equal to 4.83 meters per second. Okay. And then yung angle, which is alpha para sa velocity. Tangent inverse ng Vy over Vx. So this gives us 76.8 tawag dito, negative 76.8 degrees. Okay, tama ba yan? So x component is positive, y component is negative, so nasa fourth quadrant siya. And itong angle na to ay nasa fourth quadrant. So ito yung 76.8 degrees. Okay, na angle. Okay, so yan yung nangyari sa book. Okay, so tumama siya or just before it hit the floor, yung kanyang velocity is 4.83 meters per second. Nag-increase from 1.10 meters per second. And then yung direction is 76.8. Okay, towards the floor. Okay, along the positive x-axis. Okay. So letter D, draw xt, yt, vxt, and vyt graphs for the motion. Okay. So I made that drawing here. Okay, so ito ginawa ko to using a computer, but what you can do if you don't know how to do some coding is that pwede niyong kunin at specific time intervals. Halimbawa, dito, dyan, dyan. Okay, so 1, 2, 3, 4, 5 points. Ganun din dito, yan. So if you do that, okay, at specific time intervals, you'll get these 5 points as you connect the dots yun na lang. Okay, so halimbawa may lumabas na ganyan sa exam, ganyan yung mangyayari. Okay, then ganito yung para sa velocity along the x-axis and ganito yung velocity along the y-axis. Now, of course, we expect this to be linear, yung x versus t. Diba? Kasi nga ang expression is x equals x naught plus v naught x t. And yung y is parabolic kasi y is equal to y naught plus v naught y t. Okay, minus 1/2 gt squared. Okay, okay. I think this is an incorrect graph. Okay, dapat pababa siya. So dapat pababa siya. Okay. When I send you the notes, i-correct ko to. So when you get the notes, yung makukuha yung graph is correct. Okay. And of course, ito ay constant kasi wala acceleration along the x-axis. And then ito ay linear kasi Vy is equal to V naught y minus gt. Pero again, this is incorrect. Dapat pababa yung graph. Okay. Now, bakit ako nagkamali dito? Because dun sa next na slide, actually, I made a solution na kung saan yung axis na pinili ko is positive y downwards and positive x towards the right. Okay, so bakit ko ginawa ito? Kasi minsan, mas convenient yun. Okay, paano siya naging mas convenient? If you choose positive y downward, then your acceleration along the y-axis will be positive g. Okay, kasi pinili nyo nga, downward is positive, di ba? Sinabi nyo, downward is positive, so positive yung acceleration due to gravity will have a positive direction. So, ang implication yan is ito, okay, magiging positive, yan magiging positive. Okay, which means na tawag dito, yung y nyo ngayon, yung displacement along the y-axis is positive. Okay? Okay, which is still correct. Okay? Kasi pinili nyo ang direction is positive y. Dito, okay, pinili natin direction is paakyat, yung positive y. So negative yung nakuha nating sagot. Just because we chose a different axis. Okay, dito naman sa letter B, hindi nagmamatter kasi pareho namang towards the right yung x-axis dito, tsaka dito. Okay? Dito naman sa letter C, okay, yung Vx, okay, is constant, talagang 1.10 meters per second lang siya. Pero yung Vy, okay, ay negative dito sa solution na ito at positive dito sa solution na ito. Kaya dito makikita nyo, positive 4.7 meters, pero dito, negative 4.7 meters. Okay? And that happened again because I simply chose a different direction in this example. Then dito, nung kinuha na natin yung magnitude, it's still 4.83. At dito, nung kinuha natin yung direction, dito, both positive yung x and y components, so kaya positive yung angle na lumabas. Dito, negative yung angle na lumabas kasi yung y-axis is negative and yung x-axis is positive. Okay, so yun yung difference. And itong solution na ito, okay, that you see here is for this solution, okay, na kung saan yung axis na pinili ko is positive y, then positive x. Okay, so again, I'm going to correct this. Maglalagay ako ng additional slide, okay, para pakita sa inyo yung actual na graph para dito sa solution na ito. Okay? So I hope naging ano yun, naging klaro. Ginawa ko tong solution na ito para makita niyo na by selecting, para makita niyo yung significance ng choosing a coordinate system. There's no right or wrong coordinate system. It's how you use the system that you chose, okay, that makes your answer, okay, correct or incorrect. Okay, which yung nakita niyo obviously dito sa example na ito. Okay? Okay, so let's move to the next example. In a carnival booth, okay, tawag dito, you can win a stuffed giraffe if you toss a quarter into a small dish. Okay, so nandun yung quarter. Okay, andito yung quarter, hawak niya, kulay orange, and then dito sa taas, andun yung, okay, andun yung quarter, and dito sa taas, andun yung dish. Okay. The dish is on a shelf above the point where the quarter leaves your hand and is a horizontal distance of 2.1 meters. So from this position, hanggang kung nasan yung quarter, hanggang dun sa dish, that's 2.1 meters. Okay, if you toss the coin with a velocity of 6.4 meters per second, okay, at an angle of 60 degrees above the horizontal, the coil will land in the dish. Ignore a resistance. Okay, so anong alam natin? What do we know? Okay, so unang-una yung displacement, 2.1 meters. Okay, yung position ng dish is 2.1 meters. Lagay na natin yung origin to be, set na natin yung origin at the zero position. Set din natin yung, set natin yung origin. So, ibig sabihin, x naught, y naught is equal to 0. Okay, v naught is 6.4 meters per second and theta, the angle is 60 degrees with respect to the positive x-axis. Okay, so nakasulat yung lahat dyan. Okay. So 2.1 meters, 6.4 at an angle above the horizontal. Horizontal is yung positive x-axis. So let's draw that. Saan nyo ilalagay yung origin ng coordinate system nyo? Ilagay nyo kung saan nag-start yung motion. Dito nag-start yung motion, dyan yung positive y, at dyan yung positive x. Okay, now you have an angle, okay, a direction which is with respect to the positive x-axis. And yung velocity niya, okay, has that magnitude, 6.4 meters per second. Okay, ano pa yung alam natin? In this case, alam natin na since yan ang pinili nating axis, alam natin na ax is equal to 0 and ay is equal to negative g or negative 9.8 meters per second squared. We also ignore a resistance, okay, which means na yung coin undergoes projectile motion. Okay? Kasi iisa lang yung force, di ba, na nagko-cause ng motion ng coin, which is yung force due to gravity. Okay, ano pa ba? Tignan natin. Okay, so yun na yung lahat. Yan na yung lahat ng alam natin so far. So what we need to find is the height of the shelf. Okay, itong height na ito. Yan, tawagin natin yung height na yan na y. Okay, so ito yung y, x naught, y naught equal to 0 kasi origin siya, di ba? So sa letter A, y is equal to, ano bang given dito? Walang given na time, di ba? Pero hindi rin natin alam yung velocity niya dun sa dish. So we definitely cannot use v squared minus v naught squared kasi hindi natin alam yung v squared. Okay. So mukhang ito yung gagamitin natin. Y equals y naught plus b naught y t minus 1/2 gt squared. Okay, so if we write that yung y naught is 0, okay, v naught y, okay, so yung v naught y is v naught sine alpha naught, okay, t minus 1/2 gt squared. Okay, kasi yung v naught y is v naught sine alpha naught. Okay, yung v naught x of course is v naught cosine alpha naught. Okay, so alam natin yung v naught, alam natin yung alpha naught, alam natin yung g, pero hindi natin alam yung time. Yung y yung hinahanap natin. Okay. Ano pang iba nating alam? X. So if we do that, x equals x naught plus v naught xt, or x equals x naught plus v naught cosine alpha naught t. Mukhang pwede natin masolve yung ano dito, yung time. Kasi ito alam natin na 2.1 meters, di ba? Given yan. Then alam natin yung v naught at saka alpha naught. So we can solve for time. T is equal to x over v naught cosine alpha naught, or 2.1 meters divided by 6.4 meters per second times cosine ng 60 degrees. So this gives us 0.65 seconds. So anong ibig sabihin ng time na ito? Okay, so yan yung time from here, kung saan sinimulan yung ibato yung coin hanggang dito. And ganyan yung magiging trajectory niya. Okay. Well, paano natin alam na ganyan yung trajectory niya at tawag dito, hindi straight na ganon, di ba? Kasi alam natin yun from experience. Okay? Okay, from experience, di ba, binabato natin yung coin and then babagsak yung coin dun sa dish. Okay? Ganyan naman ang physics kasi we draw these laws of nature from our everyday experiences. Okay? Kaya nga importante na naintindihan nyo kung anong nangyayari. Okay? And maiintindihan nyo lang yan if you draw from your own experience. So yan, time na yan is 0.65 seconds. Okay, so sa letter B, ano yung vertical component ng velocity of the quarter just before it lands? So pinapahanap lang is vertical component. Okay? Just before it lands. Okay, so, oh, sorry, hindi pa pala natin susolve yung y. Okay, so now we can solve for the height. So y is equal to, i-move ko ng konti kasi baka maubusan tayo ng space. So y is equal to v naught, which is 6.4 meters per second squared times sine 60 degrees times time na 0.65 seconds minus 1/2 times 9.8 meters per second squared t 0.65 seconds squared. Okay, so y then will be equal to 1.5 meters. Okay. So, yan. So, mukha naman may sense kasi yung sagot natin is above, di ba? Or positive, meaning above nung y naught. Okay? Nung original na position niya. So, yan is 1.5 meters. Okay? Now, sa letter B, ang pinapahanap is yung vertical component ng velocity. So ang vertical component is given by Vy, okay, which is equal to V naught Y minus GT. Alam natin yung V naught Y to be V naught sine alpha naught minus GT. So we can solve this to be 6.4 meters per second times sine 60 degrees minus 9.8 meters per second squared times 0.65 seconds. Okay, so Vy then is equal to negative 0.89 meters per second. Okay, so ang ibig sabihin nito, negative yung velocity, okay, along the y-axis. Ibig sabihin, pababa yung motion ng coin at this point. Okay, so pababa yung kanyang motion. Yung component niya along the y-axis is downward. So tama lang. So ibig sabihin, tama lang itong dinowing natin na trajectory. Kasi yung component ng y, ng velocity along the y-axis is downward. And tama lang din itong result na nakuha natin. Mga results na nakuha natin. Okay, so this solution makes sense. Okay. Okay. Now, finally, we go to the concept of circular motion. Okay, so dito sa circular motion, okay, the acceleration need not be yung acceleration due to gravity. In fact, pag dinidiscuss natin ng circular motion, wala tayong pakialam sa gravity kasi tawag dito, kasi perpendicular yung gravitational force sa motion ng object. Okay, typically kino-consider natin circular motion pag halimbawa paliko yung kotse sa isang daan. Okay, yun yung mga typical na example. Or halimbawa may sling kayo, di ba, na pinapaikot nyo above your head. So yun yung tawag dito, isang example ng paggagamitan ng uniform circular motion. So tulad dun sa diniscuss natin kanina, if constant yung velocity nung object, okay, yung acceleration ng object na yun points towards tawag dito, the radial axis or points towards the center of the circle. Okay, pero if the car is speeding up, then the acceleration niya is ahead of the normal line or ahead of the radial line. And then if the car is slowing down, then yung acceleration niya is behind the normal line. Okay. So, dun sa first case, ang tawag natin dyan is uniform circular motion. Kapag yung speed is constant, but the direction changes. Dun sa second case, ang tawag natin dito is non-uniform circular motion. Okay, and yeah. Okay. Okay, and yan. So pag uniform circular motion, okay, ganito yung nangyayari, no? So same na yung V1 at saka yung V2. So itong V1 na to at saka yung itong V2 na to ay same yung magnitude kasi same speed, pero yung direction nila magkaiba. Which means na ang delta V will be in the direction of the radial line. So ito yung tawag dito yung direction ng delta V. Okay, and kung ganun yung case, kung halimbawa meron kayong object undergoing circular motion, okay, tapos uniform yung circular motion niya, yung velocities, yung speeds do not change, pero yung direction changes. And at each point dun sa trajectory, yung acceleration, yung radial acceleration specifically, okay, ay pointing towards the center of the circle. Now, contrary to tawag dito projectile motion, if you compare that to projectile motion, yung velocity changes, okay, at each point dun sa trajectory niya. Okay, pero yung acceleration due to gravity is always in just one direction. Okay, kasi dahil lang to sa gravity. Wala kayong acceleration along the horizontal. Okay, so in this case, Okay, yung radial acceleration, okay, yung expression for the radial acceleration, okay, is given by v squared over r. Na kung saan yung v ay yung speed, okay, of the object at any point, and yung r is the radius of the object's circular path. Okay? So even if section lang siya, diba? Ito section lang to ng circle. Okay? Makakabuo pa rin kayo ng circle dyan. Okay? Na mas maganda kaysa dinrawing ko. Okay? And okay, yung circle na yan ay merong radius. Okay? Yan yung ilalagay nyo na radius dyan sa expression na yan. Okay? So, anong tawag dito? We can also relate yung velocity na yan sa sa period of the motion. So pag sinabing period, it's time it takes for one cycle. So P is the period, so time for one revolution. Okay, isang ikot or one cycle. Okay. So if it's one cycle, di ibig sabihin ang circumference nung cycle na yun, since this is circle, is 2 pi r. Diba? So divide nyo yan by the period, that's your that's the speed of the particle. Diba? Ang speed ng isang ikot, ang isang ikot is 2 pi r, i-divide nyo by the period, then that's yung speed ng particle na yan. Okay? So, what about non-uniform circular motion? So for non-uniform circular motion, you use yung concepts na diniscuss natin before sa kinematics. Okay? Kinematics at saka yung definition ng velocities. Now, there are examples na kung saan yung circular motion ay parang vertical. Okay? Like roller coaster, di ba? So in that particular case, meron ka ng gravitational force. Okay, so kailangan nyo idagdag yun at incorporate dun sa sa computation niyo. Okay, so now let's consider this example. The Earth has a radius, okay, ang tawag dito, of 6,380 kilometers and turns around once on its axis in 24 hours. Okay, so what is the radial acceleration of the object at the Earth's equator? Give your answer in meters per second squared and as a fraction of g. And if the radial acceleration at the equator is greater than g, objects will fly off the surface, off the Earth's surface and into space. What will be the period of the Earth's rotation? How to be for this to occur? Okay, so start with what you know. Anong alam natin? Ang radius ng Earth is 6,380 kilometers. Okay. Now, tingnan nyo kung ano yung may require. Answer must be meters per second squared. So you have to convert this to meters. So obviously 1 kilometer is 1,000 meters, diba? So this will be 6,380,000 meters. Okay, and then ano pa yung iba nating alam? Time, yung period. Period is 24 hours. Okay. So alam natin na sa isang oras merong 3,600 seconds. So this will be 86,400 seconds. Okay. What else? Okay, so yun lang yung binigay sa atin. So we can solve A first. So A is ano yung radial acceleration? Ang radial acceleration is given by v squared over r. Pero ang v is just yung circumference divided by the period. So let's solve for the speed. So 2 pi r over t is equal to 2 pi times 6,380,000 meters divided by 86,400 seconds. So, equal ngayon to sa 464 meters per second. So, yung radial acceleration is v squared over r. So, 464 meters per second squared divided by 6,380,000 meters. So, this will be 0.0337 meters per second squared. So, yung fraction of g of the acceleration due to gravity is 0.0337 meters per second squared divided by 9.8 meters per second squared, or 0.0034. Or we say that this is 0.00. We say that the acceleration, the radial acceleration, is 0.0034 g. Diba? Kasi this is a rad and this is g. Diba? Okay. Okay. So letter B, if the radial acceleration at the equator is greater than g, then the objects will fly off. Diba? So ibig sabihin, ang sinasabi dito is if the radial acceleration is greater than g, okay, then the objects will fly off. It's a good thing na yung radial acceleration is not even 1%. Okay? Is a third of one third of 1% of the acceleration due to gravity. Okay? Kasi dahil doon hindi tayo nagfa-fly off into space. But if the acceleration due to gravity, or if the radial acceleration is greater than or equal to the acceleration due to gravity, okay, then lilipad tayo off space, off into space. So we know that the radial acceleration, ang tanong is what is tawag dito, what would be the period of the Earth's rotation have to be? What would the period of the Earth's rotation have to be for this to occur? So we know that the radial acceleration is v squared over r, or pag pinasok natin itong expression for v dun sa v squared, then we have 4 pi squared r squared up 4 pi squared r over t squared. Okay, so nag-cancel na yung r dyan, kaya r na lang, hindi na r squared. Okay, and tawag dito, ang hinahanap natin dito is yung period. So if we rewrite this in terms of period, so we have 4 pi squared r over the radial acceleration, then take the square root, that will be 2 pi times r over the radial acceleration, and then square root. Okay, so this will be equal to 2 pi square root ng, oops, siya lang malaki yung radius ng Earth. So dito natin siya i-split. 2 pi times the square root of 6,380,000 meters divided by the radial acceleration of 0.00. Hindi, sorry. Dapat equal, no? Kasi minimum is equal. No. Pwede natin gawin ay ganito. So this has to be less than or equal to g. So, ibig sabihin, we use this instead. Okay, so, papalitan natin yung A rad ng G. Okay, so 9.8 meters per second squared. So this gives us 5,070 seconds. And if we multiply this by, if we convert it to hours, then the period will be 1.42 hours. Okay? So, I'm guessing na itong, at this point sa video, it's a little more than 1.42 hours. So, from the time that you started watching this video to about this time, imagine nyo, yun yung isang ikot ng Earth. So, ang bilis ng rotation na yun, di ba? And if the rotation of the Earth is that fast, then tatalsik na tayo, okay, from the surface of the Earth into space. Okay, so yun yung ibig sabihin ng numbers na yun. Okay? So, that's it for, oh, sorry, may isa pa palang example. Okay, so last example. Pilot blackout in a power dive. So we have a jet plane that comes in for a downward dive as shown in the figure. The bottom part of the path is a quarter circle, okay, with radius of curvature 2.8 meters, 280 meters. According to medical tests, pilot will lose consciousness when they pull out of a dive at an upward acceleration greater than 5.5 g. What minimum minimum speed in meters per second and miles per hour? Dati natin ito ng kilometers per hour kasi mas familiar tayo dun sa units na yun. Okay, will the pilot black out during this dive? So again, we start with what we know. Nung alam natin, ang radius of curvature, okay, is 280 meters. Ano yung quarter circle na refer niyo? So it's probably this one. So that's 1/4 of a circle. Okay, 1/4 of a circle. At yung radius ng circle na yan is 280 meters. Ano pa yung ibang alam natin? So at a radial acceleration of 5, ang radial acceleration is v squared over r, and if it is at least 5.5 g, or greater than 5.5 g, then mag-blackout yung pilot. Okay, so if we use this as our working equation, then we have v squared over r greater than or equal to 5.5 g. And if we solve for v, then we have if we solve for v, then we have 5.5 g r and then square root. Okay, plugging in yung known quantities. Okay, 5.5 times 9.8 meters per second squared times 280 meters. And then we take the square root of that. Okay, we get a velocity which is equal to 108 meters per second. Okay, so the minimum velocity is 108 meters per second. So let's convert this to miles per hour. In miles per hour, okay, the minimum velocity is 108 meters per second. So 1 meter per second is 2.23694 miles per hour. Okay, so that's 244 miles per hour. Okay, na-imagine nyo ba kung gaano kabilis yan? Hindi, di ba? Kasi hindi tayo sanay gumamit ng miles per hour na units. But if we use a conversion, okay, from, anong tawag dito? To kilometers per hour, baka maging familiar pa kayo. So 1,000 meters is to 1 kilometer, and then 3,600 seconds is to 1 hour. This gives us 392 kilometers per hour. Okay. As a reference, a bus in the expressway, TPLEX, for example, travels at a maximum, at least yung speed limit, di ba? 100 kilometers per hour. This is 4 times the speed limit dun sa expressway. Okay? So, ganyan kabilis yung mga jet fighters na yan. So, if the jet fighter, the jet plane curves, kung ang speed niya at this point is at least 392 kilometers per hour, yung tawag dito, pilot na yan ay magba-blackout. Okay? Okay, so that's it for today. Again, if you have questions, then tawag dito, just let me know. Send me an email and para masagot ko yung mga tanong ninyo. Or we can discuss it to our Zoom consultations. Okay, so thank you very much and I'll see you at the next meeting.